in Azure, we've got such a wide portfolio of Azure networking services that we try and break it up into categories now on pillars. So we've got our foundational services, so things like virtual networks or VPCs for those of you AWS or Google orientated in the room. Our hybrid connectivity products, so how do you connect into Azure from your offices, like ExpressRoute, VPN gateways, those sort of things. Our security products, so firewall, DDoS, Bastion, and then app delivery, so front door, which is basically global load balancing, Cloudflare, that sort of style of thing, CDN hosting. And then our 5G and edge computing, which we won't touch on today because I could spend hours and hours talking about that stuff. And it's really, really dull if you're not interested. I'll be completely honest. 5G is very, very confusing and something that we'll all get to know much more, but not tonight. I'll definitely come back and do a talk on that if you're interested, but it's very niche. But massive range of products, and that is not an extensive list. That is just sort of a teaser of what's there. So let's start building this bigger picture, right? Our global infrastructure. What builds Azure, right? Before we know about networking, like when you've had data centers, you know where they are, right? You can go and see these switches, you can go and see these routers, you plug things in, right? But cloud, right, somebody else looks after that now. Like, what do these things look like? How does this get built? So Microsoft today has the most number of regions versus any other cloud provider together. So we have 60 plus Azure regions, more on the way as well. We have over 200 data centers, and we've got 175,000 miles of our own private fiber. So our latest installation is the Maria sort of cable that you may have heard about that runs somewhere into sort of Bilbao over here. So this cable here that we did with Facebook and a couple of others, incredible amounts of speed. I'm not even going to try and recall the numbers, but it's like terabits per second that go across this cable. It's the first cable that actually connects sort of mainland US to sort of mainland Europe. So it's an incredible cable that's just been run sort of just before COVID, so good timing. And we have 190 POPs around the world. So wherever you are in the world, when you're trying to get onto a service that is hosted in Microsoft, you'll likely be very, very close to that service and therefore have a good experience. All of that network's owned by us, so we look after everything on there. You know, we may share cables at the odd place, but you know that's all our leased service on top of it. So we don't use anybody else's network to get your traffic to anybody else. And that's really what we're going to say in this, right? So every piece of traffic that moves in between our data centers stays on our network. We never hand it off to any other third party. We don't go, it's a faster route there. It stays on our network, and once it's on our network, we can protect it as much as we want. And you know, we can therefore say it's all secured. So once you're into one of those 190 POPs, you're on our network and you'll stay on our network. We'll never get rid of you at that stage. Now, this is a really lovely diagram, right? And we're looking at Azure regions from like the global, right? So we've got our wide area network. There's just this thing where we connect all of our regions together. And we have these concepts called regional gateways or regional network gateways, as they're technically known, that then connect all of our data center regions or data centers or availability zones inside of a region together. And they plug all of those back into our wide area network. Now, this is a really high level diagram. So let's start digging in and start getting into a bit more technical on this. But before we do that, what do these things actually look like, right? It's always good to see a picture of these things, right? The cloud isn't in the cloud, as we all know. These things really exist. So this is Quincy in Washington. So this is West US 2, I think, from memory, if you've ever used Azure. So this is one of our regions. And this is very early days of when it first started, right? So if you take note of the car park at the bottom right, at the bottom of the screen, and you take note of these containers over here, look what it has evolved to in a recent photo, right? So this is the car park, and these are the containers. They're now on Microsoft brand, which I very much enjoy. But you can see this expansion of this data center, right? And actually in that region, we've built West US 3 now as well. So massive expansion in this area of the world. These things are huge, right? This is data centers done on a colossal scale, very unlike what we probably have all done in our own times. None of us have built data centers of this scale. I might have done 40 racks. That's probably one of my bigger deployments, but you know, nothing to this sort of scale. And that's not just in the States, right? This is Dublin, Ireland, so North Europe, one of our first regions in sort of nearer to home for us. And again, looks fairly big, right? Okay, keep note of the grass on the right-hand side. We're going to do a bit of a 360 and have a little bit of a spin. Well, we filled that and put another data center in alongside it. And, you know, okay, it looks fairly different. And you'll see different generations of data centers that we do, different economies of scale. So, more better cooling, all of that sort of stuff as we modernize. So you'll see different shapes and sizes of data centers as we go along. But Dublin's gone a little bit further than that. What you were just looking at is DB 3, 4, and 5. This is now North Europe, and this was at least, I don't know, 2019, probably before then, this photo. So it has probably gone on a lot more since then, right? And any of you seen the recent Panorama documentary that was out about cloud computing? Yeah, Norway, and they mentioned Ireland's power consumption. Very much like this is the sort of scales we're talking about, right? These are massive. You will find this on Google Maps. You can go and have a little look at this one. Yes, Keith.
What is Microsoft doing about their power and green footprint of their massive data center expansion?
Good talk. We have a lot of sustainability stuff. So carbon neutral by 2030, and then taking all of the carbon we've ever put back into the atmosphere since 1970 by 2050. So lots we are doing on that front. Go and read it. Go and Google Microsoft Sustainability. It's incredible. The report came out just after Christmas for last year's report, but doing a good job. And with this, building massive data wind farms and stuff like that to try and reduce this. But obviously, people need the cloud, so we have to keep building, but we also have to do our bit for the planet as well. But yeah, these things are absolutely massive, right? So when we talk networking and we see that easy diagram that we just saw, it's more than just a few cables. We now need to try and break it down into Azure terms, right? So who's used Azure in the room? Let's get a show of hands. I've got some rough idea of numbers. We'll convert you, don't worry. So we break things down into geographies at a very, very high level. And geographies are, things like the UK is a geography, Europe is a geography, the East US is a geography, right? We break things into these really high level concepts. Now, they really mean nothing to you when you're building Azure, apart from data residency and sovereignty, right? That they'll become important. We then have regions, right? So these are things that you actually deploy resources into in Azure. So you will pick a region. So UK South is a region, or North Europe, the Dublin data centers that we've just seen, that is a region. Within those, we have things called availability zones. Now, they aren't available in all of our regions. Most of them, and any new data centers that we build going forward will, but we didn't have availability zones as a concept when we originally launched Azure. We've added them versus AWS and GCP, who had them from sort of day one, and they built that way. And then within availability zones, which could be multiple data centers, right? They are not just one building. That could be 3 or 4 of those buildings all together that makes one availability zone based on capacity. And then inside of those, you have things called availability sets, which are becoming less popular because we have zones now. But this was a way of keeping VMs off of the same set of hardware in a rack so that you'd have a bit more fault tolerance. But that's how we build things together. We then have this concept of region pairs that we will group regions together. So UK South and UK West are region pairs. So when you enable any of our storage services that have geo-redundant storage, it will always go to its region pair, right? And they've got really super high bandwidth between each other so that they obviously are asynchronously replicating lots and lots of data, but they've got the capacity to do so. There are, you can, with certain services like Cosmos and SQL, you can choose other regions to sync your data to, absolutely fine. But out of the box, the best performance you're going to get for replication is to go into its region pair because they're built for that purpose. And every region has a region pair, even Brazil South, which goes to somewhere in the US. It's a long way, but it's where it goes. But most of them have something very close. So North Europe is paired with Amsterdam in West Europe, right? All very, very high bandwidth throughput. So these are availability zones, as I was saying, right? They are completely independent: power, cooling, networking infrastructure, all of those things. We always have 3 zones. So if a region supports it, it always has 3 zones. So you can pick to deploy in any of those zones. And those zones can be built up of multiple data centers, right? So it's not just one building. Don't think of it as one building. There are lots of them in there. And this is what we define as our latency sort of tolerance, that what defines what can be in an availability zone or not. So if it's intra-availability zone, as in it's in the same zone, it has to be equal to or less than 0.4 milliseconds, right? So very, very much synchronous territory, right? You can do synchronous data commits at that. It's very, very quick. Inter-availability zone, we want it to be less than 2 milliseconds. That's what we document, that's what we say, and that's what we guarantee. So between different availability zones within a region, and these could be 50, 100, 150 kilometers apart, It has to be below 2 milliseconds. That's what we absolutely guarantee, because you can still do synchronous data commits at that stage. You're not in the world of asynchronous data. So massive scale to give you ultimate flexibility in terms of resiliency and redundancy. And as I say, rolling out to pretty much every region nowadays that we're building, but there's still a few that don't have availability zones, but there's always plans to get them added. And this is what one looks like from a pretty picture. So as you can see, one or more data centers makes up an availability zone, and they have diverse fiber paths connecting each of them. So one availability zone going down doesn't impact another availability zone. And that's where we'll come back to in a second. Obviously, we have our region pairs as well for disaster recovery. So if you want to go to another region, this whole region goes down, you can go to another region and use another availability zone over there. And that's within a geography, as we were talking about earlier. But let's start bringing this back into networking, right? So we're now talking about regional network gateways. Now, if you notice those black boxes in the bottom right-hand corner of DCs, each one of those grouping is an availability zone, is a good way to think about this. So as we step through, each one of those will connect to a regional network gateway. Now, these are different facilities that just host networking equipment, right? They are built just to connect you to the Microsoft backbone and all of the other regions together. Massive scale, as I said, 2 milliseconds round trip time. That's our goal for availability zones traffic. And all the data centers only contain compute and storage hardware. They don't contain networking kit, only enough to connect them back to the regional network gateways. There's no clever stuff inside of the data centers. They're built to just be stamped out and keep growing and growing and growing as we go. The regional network gateway is where all the clever stuff happens. So when we start adding more and more regions, we just start following this, right? You can imagine this with 100 regions or however many regions we want to add. The same pattern happens. We build this Microsoft backbone, which is that massive 175,000 miles of our own dark fiber that we can connect all of our networks to across. And we keep expanding and expanding. Now, you may be thinking, cool, where's the internet come into this, right? Because we all use the internet to get to the cloud service. Well, we plumb that into the Microsoft backbone from a logical standpoint, right? Obviously, we have local internet breakouts everywhere around the globe, but that is managed from our Microsoft backbone to make sure that we can route IP addresses and whatever we need to from the internet wherever we want to under our control, right? So it's not like, well, this is tied to here. We could move things around as we need to because it's plumbed into our backbone and we're in control of it on our software-defined network at that stage. And, what about private hybrid connectivity? Like, how do businesses connect into these clouds? Well, before we do that, you need to understand a little bit about what ExpressRoute is. So ExpressRoute, for those of you who don't know, is basically a physical private cable between your offices or data centers to a Microsoft Azure region, to the Microsoft Azure network. So you can route your own private traffic between, so direct connect in AWS terms, and I always forget what it's called in Google, but somebody I'm sure will shout out or tell me at one stage, but effectively a private cable between your offices and data centers to Azure and your services up there. Low latency, high throughput, pretty quick, come in various shapes and sizes in terms of how much you're willing to pay.
Is it the same private?
No, Private Link is called Private Link actually in Azure, probably one of the only services that actually match up as a name. But we'll come on to Private Link in a second. So this is all about allowing your network on premise to have direct connectivity to your services within Azure over your own dedicated line. So not going over the public internet. It comes from 10 to 100 gig, and you can have that with a partner involved in the middle. So somebody like BT or Vodafone or whoever else, level 3, there's lots of network providers out there. Or you can do it yourself and come directly to us, and you can peer in one of our locations and have a ExpressRoute direct. And that is super high latency. They come in a minimum of 10 gig to 100 gig. But we see lots of customers use those. So that's what ExpressRoute is under the hood. We also have VPNs. So for those of you who might not be able to, need an ExpressRoute, but still want that private connectivity, you can also deploy a VPN gateway. So you can build an IPsec tunnel between your on-prem and Azure. And we've got a service that does the Azure end of that. So you can connect privately to your services, but obviously it's over the public internet. And obviously the latency and throughput is not as great. But, it is definitely an option that we see a lot of customers go for. So we can now draw that onto this diagram that we're starting to build, right? So if you imagine our customer site over here on the left-hand side in purple, We then got these carrier neutral facilities, so like telehouse, where it's just a meet me point where lots of IXPs just connected to each other and lots of people just connecting to each other. We will have our own routers in there, as you can see, called the ones in blue with MS above them. So we have our routers there that connects into the Microsoft backbone, and then various carriers. I didn't draw many on here. I just drew the one, for example. But you can have hundreds of carriers in here, right? I think there's well over 100 partners that do ExpressRoute with us. You can choose one of them to connect to your last mile, and they connect directly to us. And that's how your ExpressRoute connects through. So you have a relationship with your provider like BT, they connect to us, and we pass you logically through into our network. Exactly the same as everybody else does it, but you're starting to build this picture of how all of this gets joined together. All right, well, we came to talk about Azure networking, Jack, right? You talked a lot about not things in Azure, so like what we're going to get into next. Before we dive into Azure networking, you need to understand what a virtual network is. So a virtual network is a VPC. That's probably the best way of explaining it. Some key differences with VNets, as we shorthand them in Azure, to VPCs are they span availability zones by default, and subnets span availability zones by default, and you can't choose them not to. So all of your subnets span all availability zones by default. So whereas in GCP and AWS, your subnets are pinned to a zone, but your VPC isn't. You can put your own IP address space in there. You choose what your DNS servers are. You can carve that up however you see fit. You choose your DNS servers, your security rules, how traffic flows with route tables and all of those things. But it's your boundary, right? And it's all software defined. So you don't need to think about this like a VLAN or anything like that. Those concepts are dead when you go to the cloud. It's all layer 3 only. And this is what a virtual network can start to look like, right? So you can have virtual networks connecting to each other. So you could have a hub virtual network where you may have your network appliances and your ExpressRoute connectivity or your VPNs. And then you will have multiple other VNets that might have your applications in, right? And these might be in different subscriptions and all of that, but we'll leave out all of those constructs today because there's enough to take in. And you can connect all these things together with something called VNet peering, which I will come on to much later. So now you understand what a virtual network is, right? It's basically where you deploy your resources within Azure. It's where you put your things that you want to keep private within Azure. We can start drawing this out even further. So let's first of all talk about some PaaS services. So Azure SQL, Azure Storage, Azure App Service that we've got shown on here, they all have an internet routable public IP address issued by the Microsoft backbone, right? So they are handed out. When you provision those services, you'll get a public IP address. Most of them are multi-tenanted. Some of them will be dedicated. But the public IP address you will get will be publicly routable from the internet. You can then deploy things inside a virtual network in your own subscriptions as well, which might be things like virtual machines, VM scale sets with load balancers or VPN gateways. The public IP addresses that you can associate with those services also get issued from the Microsoft backbone. So they are all internet routable. So once you see that public IP address, you can hit it from wherever you are, right? It's a public IP address. It's nothing hidden. There's nothing magical about that. So how does traffic really flow, right? If we took PaaS to PaaS in this example, so let's say we wanted to get from the app service, which is the globe in the bottom right-hand corner, to the SQL server in the left-hand side, how would that work, right, from a traffic flow perspective? Now, remember what I said earlier around all Microsoft traffic stays on the Microsoft backbone, right? Even though they're publicly routable addresses, this traffic isn't going to leave Microsoft. So this traffic flow will literally pop out through a regional network gateway, through the backbone, back in, and pop in to a SQL, right? That's technically, you could call that private because it's never gone to the internet, right? But obviously a lot of people won't because it's got a public IP address, but it has never left the Microsoft backbone at that stage. And that is by default. You don't have to do anything. You don't have to pay for anything. That is just how our network works. So you get the best performance between any of our services if they're staying within our network. Now, what happens if we were talking about, adding in PaaS to IaaS, right? So if I just bring in the other stuff where I forgot what my animations did. So if we're now talking about going from like a virtual machine, or we're saying that this app service in the bottom right again wants to go to this virtual machine scale set in the bottom left. So the green bit here with loads of VMs. Say it was another web API talking to another web API, just different services. Then again, there's nothing different that happens here, right? It goes exactly the same route. back through a DC into its public endpoint, but all over the Microsoft backbone. It's never leaving our network. That's the point I'm trying to reinforce here when we're talking about public routing. But what happens if we're not talking about public? We're talking about IaaS, right? Your own VMs, something you've brought to Azure, and you want to connect them. Now, there are multiple ways that you can connect these things together within Azure. One way is by VPNs between them. So you can imagine a VPN between these two virtual networks, right? You can do that, absolutely supported. Before VNet peering existed, this was the way you had to do it, and still gets you out of a lot of holes today when you have some complex routing challenges today. But effectively, we've now built a tunnel between them. So if this VM here wants to talk to this VM over here, it will just go over that tunnel, right? And technically, that traffic flow is going all the way over here again, but it's never leaving our network, right? That public traffic flow is technically doing that, but the tunnel between them is going between these two VNets. What happens if we had ExpressRoute, right? So one of the lesser known things, so say you've got an ExpressRoute over here, and you're connected via one of your carriers into the Microsoft backbone, into both of your virtual networks. So there would be a connection from here into this virtual network gateway and a connection from here into this virtual network gateway. What you can then do is if I change color, let's go there. What actually happens is by default, that not a lot of people realize is your traffic will actually hairpin off of an ExpressRoute and go back between services. So you can use the ExpressRoute as a sort of a transit network between your Azure virtual networks. Not something we recommend, not something that isn't unsupported, it's very much supported, but obviously you have latency involved in that because you're going pretty much all the way to the edge of our network and then it goes, whoa, 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 it's over here. And it turns back around and it comes all the way back in and goes to the right region and right service within Azure. Lots of people use this, lots of big customers use this functionality, but not what we recommend. So what do we recommend, right? You talked about two options that exist and work, but what do we recommend? Well, a concept called virtual network peering or VPC peering for those of you who are AWS or GCP inclined in the room. And what that really means is just in the software defined layer, a connection between these two things on the platform. All that does is effectively makes a larger VNet, right? A lot of people think about this as a cable being stretched between the two of them. It's not really how it works. All that happens on the software-defined layer is that virtual network now is bigger. It now has two virtual networks inside of it, and those address spaces are known by all of these things because all of the routing and all of the networking inside of Azure is done at the Hyper-V switch layer. It's not done in routers and devices and stuff like that. It can't. Like, you imagine the size of a router that we would need to have a massive multi-tenanted platform to be able to cope with that scale. You have to do it in software and you have to do it at the edge. So it's all done in the Hyper-V switch driver, and that's where all of our networking stack happens. So yes, it is Hyper-V, spoiler alert. So yeah, it is all Hyper-V under the hood, but well documented and lots of great white papers you can go and read on in more depth about this topic. But when that happens is these pieces of traffic are just literally bouncing between the backbone still from a technical flow perspective, but it's the most efficient and the fastest way you can do it. And also the cheapest, right? Guaranteed latency. It's going to be the quickest, no hops to go through. It's just going between the hosts. Very, very efficient way of doing it. And it also supports global VNet peering, which is what I've drawn here because we're going between two regions. So you can peer between any two VNets in any two regions. You just can't have overlapping address spaces, obviously, because they're the same routing domain. And this is what virtual network peering looks like in another diagram, right? So if you want to connect three different VNets together, you absolutely can. They are non-transitive, which I believe is the same as AWS and GCP. It's pretty much a cloud networking thing. So in this example, VNet A up here, so this VM cannot get to this VM by default, even though they're peered and there's logically a way through it. What we would have to do is set a route table on one of this subnet here that says, hey, if you want to get to VNet B, you need to go via this MVA over here. If I drew it to the right VM, and you do this reverse on VNet B that says, hey, if you want to get to VNet A, you need to go via this MVA here. And then the NVA in the middle is the middleman, and it knows how to get between both. And the traffic has originated from a peer, and therefore the cloud networks don't drop it. So VNet peering, superb, like use it every day, take it for granted. But when we didn't have it, it was a real pain. And you ended up building VPNs everywhere. So what about on-premise? So who's heard of the term hot potato and cold potato routing? Does anyone want to take a stab at what that really means? The name's like, the game we play as a kid, right? Hot potato, right? You threw something around. Like if I threw a hot potato at somebody in this room, you're going to throw it to the next person because it's hot. Pretty much the same scenario, right? So, but cold potato. So we've talked a lot about Microsoft keeping everything on our own network. If we've got an app service over here in the bottom, down in this corner that we want to get to from a customer, right? So we're a customer over in that top right-hand corner up here. If we're following the cold potato, which is the default in Microsoft routing preference, when I want to get to that service, I will be taken to the closest possible Microsoft POP, and then get me on. Basically, as Microsoft, we want you to get on our network as soon as possible because we can do a better job than the internet can. It's pretty much the concept. So this router here is way closer to me as the customer than any other router. So my traffic will go here. As luck would have it, this is a Microsoft POP. I'm now straight into the backbone, straight down to my regional network gateway, and I'm to my service, right? The least amount of hops possible, cold potato. It's been thrown the least amount of times. But what happens if we turn this on its head and we do hot potato routing? So when I build my slides, say we want to do that same thing again, but now we want to follow the preference of hot potato routing, which is cheaper for us as Microsoft because we don't want to get you on our network very early. We take you onto our network as close as possible to where that end destination service is. So this router here, let's argue, is the one that is closest to the service that we're trying to get to, which will be the same SQL database down here. Well, what would happen here in hot potato routing land is this ISP would take it. They would go, I don't know about that, but this one does. 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 Oh, this one actually does know where it's going. And this will then pass it through our network and back in the same way. But all of that heavy lifting of that original network routing to get that packet to where it needs to be done has happened on the internet. So it's hot potato. So all of the ISPs, so BT have thrown it to Virgin, Virgin have thrown it to Vodafone, Vodafone has thrown it to level 3, right? You imagine how many hops and how many bits of processing you've had to go through. The decrease in the impact on performance that you go through from that is actually quite high when you scale that up, right? So Microsoft by default does cold potato routing. We always did. And actually we added this as a feature, weirdly, about a year ago that says, hey, if you want to use hot potato routing because it's slightly cheaper and you use less of our network, but you've got really high throughput and you don't really care if it goes on our network or not, you can choose that your public IP has got a hot potato routing preference. So when you go on a storage account now and you create a storage account, you'll see it's like public routing preference and it'll be hot potato or cold potato. That's what that means. Now, a default's cold potato because we want you on our network and we can look after it much better and less hops. But if you've got really high throughput and you want to use the internet and keep it cheaper from that public IP address cost, that's what you can do. But we're talking, massive economies of scale here. Like, it's not something that your average customer is going to be like, I'm going to save thousands by choosing cold potato routing. You can't switch, by the way, once you've deployed it as well. Standard cloud caveat, right? Once you've deployed it, it's there. But that's the sort of thing. So it's really important to understand that this is how stuff routes by default on the internet. And some other cloud providers don't talk about this because they do hot potato because they don't own their own networks. They don't have that ability that we have to do with a lot of our stuff. But they are slowly moving into the cold potato world. All right. And this is it really in a more simple diagram. So your top is routing via the Microsoft network, your cold potato routing, so a lot less in between. And the bottom diagram here is routing between your ISPs, so they all pass it between themselves and throw it to the Microsoft POP that's closest to the service. All right, that's a lot of talking. I have a lot more slides, but I'm going to stop and grab a drink. Have we got any questions in the room while I do that? Go for it.
Kind of a newbie question. What is POP?
POP, point of presence. So it's literally a Microsoft router that exists somewhere as close as possible to wherever that is. So a POP. So I think so for example, there's one in Telehouse. So London Docklands. So there's two there. They're big POPs, and that one actually connects into Amsterdam. But it's where you would go to access another network, basically a point of presence. Any other questions whilst I recover?
Whilst we are doing questions today,
I shall do. The question was, what is a POP? for people who are recording.
I'll let you off on that one.
Sorry, Charlie, I will be better. All right, now I have slides for pretty much every one of these services, and I'm going to whistle through these at rapid pace, but please do stop me and ask questions, right? This is meant to be a very much this is everything that's possible. But if you've got questions about how things work together, I'm more than happy to get into the nitty-gritty and explain those things. So we talked about a virtual network. A virtual network is where you deploy your virtual machines, where you deploy anything that you want in your private network within Azure. They live within a subscription. You can have 10,000 of them in a subscription, and you can have pretty much unlimited subscriptions. So you can have lots of them. They can have overlapping address spaces as long as you don't want to connect them together. And you can now expand your VNet address space if it's peered and sync both sides. So before, if you had, in this example, these two VNets here were peered, if you wanted to increase the address space of, say, this network, you'd have to break the peering, increase the size, and then re-establish the peering. Pretty painful. You can now do that on the fly, and you just click a button and we update all the settings behind the scenes on the platform, and off we go. So yeah, really, really useful stuff. Inside of a virtual network, you carve up subnets, and you can carve them out of the address space that you assign to it, however big you want. Obviously, Microsoft will take 5 IP addresses out of that CIDR block you assign to it, because we need to do 1 for the broadcast, 1 for the network, and then 3 for our routing stuff behind the scenes to make your stuff work. But that's effectively it. You can attach things called network security groups, which we'll talk about a little bit later, which are basically like ACLs to those services, although ACL means something different in GCP and AWS. ACL in GCP and AWS is very much a stateless ACL, so it's like this thing can get to there. Like Keith will remember, like the Cisco days that we had to, like, this can go out, but it might not be allowed back in. Whereas an NSG is more like a security group in AWS and GCP terms, which allows flows both ways. So if you allow the flow out, it'll automatically allow it back in as long as it's part of the same session. So more of that networking concept.
Kind of a bit layer 2 as opposed to layer 3, because it doesn't sound like there's much point making layer 3 boundaries. You've got a big layer 3 address space, but why bother carving it up into subnets when you can just use the security layer on top?
So yeah, so the question was, is there any point in, no, it's my bad, because you got there before I did. So the question was, like, is there any point in carving these things up? If you've got one large VNet, then why not just have one large subnet and dump all your stuff in, right? So you have to have a subnet. You can't just put something in a VNet. It has to be in a subnet. But you're absolutely right. Like, that's a really good way of thinking about it. The nice thing about carving it up into subnets, though, is subnets are attachment points for things like network security groups, route tables, which you can then start to influence and build virtual boundaries within a virtual network. So I could, in this example, like you've got one over here, you've got a DMZ subnet and a backend subnet here. I could carve out the security group rules to say that the DMZ can never talk to the backend and that sort of stuff.
Route thing as opposed to a routing thing.
Yeah.
The necessity of routing isn't there anymore because you're on a big fat fast backbone that you don't care about.
Yeah, in some senses.
In the goodness of your heart, isn't it?
Exactly, but I could have this UDR here, which is saying here, so a user-defined route, which says all of this DMZ traffic has to go to this firewall in the hub. But I don't have to say that for the backend subnet, right? So that's the nice thing about it all being software defined. I can carve it up and I can choose what goes where, but I still have the same problems of I need to make sure that's symmetrical and all of those things, because networking's networking, right? It doesn't get magically fixed. So you still need to make sure that things go the same direction. But yeah, a lot of people do get caught up on, how do I carve this up and stuff like that. It really depends on your security requirements. But NSGs is where you attach to subnets. So you typically would carve them up for your front end, your back end, your middle tier, your app tier, that sort of stuff. But the option's really yours. You do see some customers just have one large subnet. I would probably advise you not to, because a lot of our other services might require a subnet to be delegated to them. So like if we're going to inject a service into them, like a PaaS service into that subnet, so that it appears as if within your virtual network, that will need its own subnet. So you can get caught out, but you can always increase the address space and add stuff to it. So it's pretty flexible. Virtual network peering we've talked to, connect 2 VNets together. No spoilers there, very simple. We have something called virtual network NAT, which the GCP and AWS people in the room will be like, oh, we had that from day one. Yeah, it took us a while. It took us a little while to get there. But effectively, if you're going, so everything in Azure can talk to the internet by default, just straight out, like you don't need anything, it can talk. Nothing can talk back in unless you attach a public IP address to it. But anything going outbound can talk. And that's really annoying when you're trying to say, like, this IP address is whitelisted from this service, because that IP address could be anything on any day at any time, right? And it changes. It's a bit like being at home and like your IP changing from your ISP at home. We then built a service called NAT Gateway, which allows you to attach it to a subnet again. So you attach a NAT Gateway to a subnet. So they're quite important to carve things up. And you can control a block of IP addresses that it will always come from. So you can say it will always come from this pool of IP addresses or public IP addresses, or this individual public IP address. And it also helps you get around some of the port exhaustion issues that we quite commonly see when you smash one individual public IP address and stuff like that. So yeah, really, really cool. Configures at the subnet level, built in auto scale. You don't need to worry about resilience, any of that stuff. It's just handled by the platform, but you just attach it to a subnet. But unlike AWS and GCP, where you say route via this NAT gateway, you don't do that in AWS. You just literally attach it to the subnet and off it goes, and happy days. Basically easier whitelisting and cheaper. We've got this new concept of virtual network manager, which I'll be honest, I've spent a little time bit playing with, but we've got some customers who are deploying thousands, if not tens of thousands of virtual networks at scale. And they're worrying about, how do I keep this like security posture, and how do I make them all talk to each other and enable all these peerings every time I enable a new VNet? It's really tedious. You know, if you've got a full mesh topology where you've peered every virtual network to every virtual network, and you've got 100 VNets, you've got 100 times 100 virtual network peering connections to create, right? So it gets a big problem. And if you're not doing it via code, that's a lot of clicking in a portal. Virtual Network Manager now helps you automate this, right? So you can create tags. So when you say you create a virtual network, you can say tag it in this, and it will automatically create the topology for you and do all the peerings and handle it. So very, very smart, cool service. And it's growing in a lot more features are coming to it. So it also has something called security admin rules, which I'd highly recommend checking out. If any of you have ever had the requirement where this port must always be open for this monitoring service to be able to work, and you've got lots of ACLs to control, we've built something in Virtual Network Manager called security admin rules that is filtered before the network security group rules apply. So you can say, always allow this traffic, forget what the app team have configured in their security group. This has to go through, right? So you can basically take that control out of the way of them, get it through, which is really, really neat because it's a big problem sometimes. And you can also have the opposite, right? So say if you went, we are blocking 3389 and 22 across the whole organization, doesn't matter if they open up their NSG, you can do the reverse with security admin rules. You can say, this is always blocked, doesn't matter, don't care who, unless they've got permissions to touch the virtual network manager config, which you wouldn't give because it's done at different scopes within the Azure RBAC model, then you can let your app teams go wild and think they've got control of their kingdom, but they really haven't. So it's a really, really good service. And lots of things are coming to this. So one to definitely keep an eye on. It's not GA yet. Don't quote me on that. Not quite sure. It should nearly be, but it's been in public preview for a little while, and it's very good. I've been using it a lot with one customer, and very, very powerful. Yo, go Keith, go.
So how would I see where my traffic is getting blocks? Because that's always the lane of good I've been networking. My network doesn't work.
That's the reason I got into cloud, Keith, because I got fed up with these two saying your VPN doesn't work. So I just started doing the other side as well. But the question was, how do you know where stuff's being blocked? Can you check? Like, where do you watch your logs? Where do you check for those things inside of your network? Hold two or three slides. We'll come on to it. Root server is a new thing. So the cloud talks BGP. Who knows what BGP stands for? It was a nickname of mine at one stage at one company. Border Gateway Protocol, absolutely. Cloud all talks layer 3. BGP is the way that people, networking devices talk and share routing information between each other. Before in Azure, you couldn't exchange BGP directly with Azure. And it was really painful when you were doing highly available like MVA scenarios, or you had an SD-WAN solution. You ended up having to plumb a load of static routes in at the last minute, and you'd be like, oh, it's all really nice and shiny. It's all automated. Now I've got 30 static routes in there just to make that thing work for Azure. We built a thing called Azure Route Server, which is effectively a BGP endpoint inside of a virtual network that you can talk to from your router. So if you've got an SD-WAN appliance like a Meraki or something like that, you can build a BGP neighborhood relationship with the route server, and they will exchange routes. So you haven't got to now plumb routes manually. So really, really smart, really powerful, and has saved lots of people deploying VPN gateways for no reason to build BGP relationships to. So yeah, fairly new, but probably a year old, but really powerful in those complex networking infrastructure. Who's a Kubernetes fan in the room? We built CNI. You're welcome. So CNI is all about having those pods or your containers being able to talk and get an IP address directly from the virtual network. So instead of them being hidden away in like a service or a mesh network or a network that is double natted, you can get them to have their own IP addresses from your virtual network, which then means they can get back to on-premise, they can go wherever else. So pretty smart, but obviously Kubernetes uses an awful lot of IP addresses, so be careful, is what I would say. And I think we've built a new thing that meshes on top of this as well recently. But yeah, we have a thing in Kubernetes. It's not my world, as you may have gathered from the talk. But yeah, we have a thing that allows it to talk natively to the Azure Virtual Network. PaaS services, lots of them. It's how the cloud started. It's how we probably thought the cloud should have been, and then realized actually people want VMs still. So we then built VMs very quickly, hence why we've got different journeys to AWS and GCP. When you've got these PaaS services like a storage account, a SQL database, a HD Insight cluster, Key Vault, these things are all massive multi-tenanted platforms, right? Running our subscriptions that we look after and provide as a service to you to consume. But some people want these on their virtual network so they can secure them and control them with their own network security groups and those sort of things. We have two patterns. We have one where we deploy the actual service dedicated, so not multi-tenanted, into your subscription and into a virtual network. And we call that virtual network injection. So Azure NetApp files, that is the virtual network injection. We inject that service into your virtual network. You consume it directly from there. Off you go. The other option, like storage, where it's a massive multi-tenanted platform, but you want to route privately to that service, we call VNet service endpoints, or private link, as we'll get onto in a second. So we had service endpoints, and it was basically we just injected a load of routes that said, look, it goes over our backbone, don't worry about it. People still weren't happy. People still wanted a private IP address in their virtual network for a service. We built private link, which we'll get into in a second. But service endpoints does exist, less commonly used now, though, because of private link. So what does VNet injection look like, right? You deploy your service, we manage it, but it is injected into your virtual network and your subnet. You don't have to worry about the service there. All you have to worry about is allowing the network rules that we require for that service to work. But you access that traffic from on-premise, from your virtual network, as you want to. We then have VNet service endpoints, which I say is routing out from your network to a PaaS service that is multi-tenanted, but over our secure backbone, which, as I say, has been really replaced with private link, which we'll come on to hopefully now. It's almost like I put the slides. So private link is private link if you're used to it in AWS or GCP. So it's a network interface that you put in a subnet in your VNet, and it talks directly to that instance of your storage account that you've connected it to, the SQL database you've connected it to, whatever. So it's basically enabling private communications to your PaaS services. Now, you can also build your own services as well. So if you can put anything behind a load balancer in Azure, you can put a private endpoint attached to that load balancer. Now, there's some really cool architecture that I've seen where you basically get rid of VNet peering and you do everything over private link, so you can overlap all the address spaces all the time, because part of private link, we actually handle overlapping IP address spaces as well, because it gets encapsulated along the way. It's very, very smart. But the nice thing about private link as well is it allows you to get to it from on-premise without having a different kind of ExpressRoute peering. So if you wanted to get to a PaaS service before from on-premise, say you want to get to Azure storage from your ExpressRoute, before private link, you would have had to have done either service endpoints and made sure those routes got filtered down, or you would have had to have done a Microsoft peering, which is basically then announcing some public IP addresses from your network to Microsoft, and we announce all the public storage account IP addresses to your network, so they go over this private link. And it was a bit of a faff, if I'm honest. Not a lot of people really got through the end of setting it up because they didn't own their own IP address space, and then ISPs would charge them loads of money for IP address space and all that good fun. So we built private link because then you just get a private IP address and it just goes in your VNet, and like you can establish that very easily and off you go. So it also handles off the data exfiltration point, because you only can use that private endpoint to get to your instance of your storage account or whatever PaaS service you've enabled it. It's not like you can now get to all storage accounts down this way. It's like, no, you can get to this storage account called this only. It's not a blase open tap.
In that sort of scenario, would you still have to authenticate back in the storage though?
Yeah. You don't change it. So the question was, do you have to still authenticate, or do you does it remove that layer? Absolutely not. Identity, RBAC, all those things are still in place. You just get to it privately now. It actually does a DNS CNAME hack. So say you were going to jack.blob.core.windows.net, which would be a public storage account address space. You change nothing when you do that with private link. You still go to jack.blob.core.windows.net. But what happens is when you're in, it does a CNAME hack. So you can look this. If you do a DNS resolve on a public storage account, you'll see it try to go to privatelink.core.blob.windows.net. If it doesn't get a response, it will just carry on and you'll go to the next resolve and you'll get a public IP address response. If you do get a response, which you will do if you've set up private link and you've set up your DNS correctly, you'll get a response of a private IP address and off you go and you get in. So it's basically a clever DNS hack, which has its pros and its cons.
To get to an AD domain when you're offline, is it type stuff like that?
Similar, a bit out of scope, but a long time since I've touched AD, I'll be honest. But not really in that sense, because this isn't offline as such. You're literally using it to get a different response to a different IP address. So example, to get to this 10.0.0.5 address, that you would need a DNS zone to associate to get to that thing, but you can't change the DNS name because you break certificate mismatching and all that stuff. So SNI goes haywire if you do that. But yeah, private link is the replacement of service endpoints is pretty much a good way of thinking about it. So you'll see lots of services add support for private link, but very little will add service endpoint support going forward because there's no need.
Can I?
Yeah, of course.
As a platform vendor, you want to offer a single tenant SaaS running the compute, but you want to have the data within your customers. BBC is the private link is what it's for.
And the storage could,
That's right. Go on.
The storage could be blob or database.
Yeah. So as long as the service supports private link, which pretty much all of them do now, you can exactly in that model. So if you're an ISV or a SaaS solution provider, you don't have to worry about what the customer addressing is their side. They don't have to worry about where you've got your side, because you can attach a private endpoint, or they can attach a private endpoint their side. You can attach a private endpoint. Depends which way you're going, right? It's only ever inbound for private link, so it's not a transitive. It's not like an IP address you can use to go both ways. So if you want to get to your customer's data, they would need to expose that via a private link service. So say they've got a storage account in their side with their data in. You can then provision a private endpoint in your side that connects to that storage account across tenants, across subscriptions. None of that matters. They would have to approve it. They would have to say, yes, we approve you to connect to it. But once that's done, yeah, you're in. And then obviously you need the authentication done at the next level, as in the actual RBAC at the storage account level to get in, but you're in. And then if they wanted to get something from you, you just flip that flow around. So if you've, say, got a SQL database that you want to give them access to, fine. So yeah, so if you wanted to get access to their data, but you wanted to pull that into a VNet that you own where your compute is, and you want to crunch it, yeah, you could get a private endpoint in your VNet for their service in their world. They have to approve it, but yeah, you don't have to worry about overlapping address spaces, anything like that. You're in at that stage. You're good. And you can also build your own services, as I say. So if you did want to expose your compute cluster to your customers and say, yeah, you can hit this API yourself, but you don't want to have to worry about going over the public internet or anything like that, put a load balancer in front of it, and they can connect a private endpoint their side to that load balancer, and they can now get in and do that stuff. So as long as you can expose it via a load balancer, because it's very, very powerful, lots of great documentation on it. Yeah, go and have a little look. Like, amazing service, especially for overlapping IP address spaces, which has been the bane of my life for the last few months. DNS. Everyone needs DNS. the world doesn't work without DNS. We have public DNS zones. So if you go to my blog, jacktracey.co.uk, it runs off an Azure DNS zone. 100% SLA with Azure DNS. 100%. It has gone down. But only once, and it was fine. It recovered quickly, and it was only the odd query that when it wasn't complete outage, it was just like some name servers had a bit of an issue. But it's fine. It's all fine. Still 100% SLA, so you would have got money back if you were impacted. You'd have had to request to get money back, but you would have got your money back. Yeah, exactly. But you can host your own public DNS in Azure. Really easy, nice API to interact with. Physical resource inside it, resource within your Azure subscription that you can manage and do what you want with. We also have public DNS zones, so as I was talking about there, and we also have private DNS zones. So if you want to build your own or you're doing private link, you will need DNS zones, but not in your scenario because you don't care about DNS in SaaS ISV world. You do, but not for this scenario. You don't need it for private link. And as you can see, this has got private link.database.windows.net. So that's the SQL equivalent. So it will just be database.windows.net for SQL servers. If you're connected to Azure, it's a DNS hack. But you can build this, you could have jack.local, you could have, Brighton cloud.internal, whatever. You can build your own private DNS zone for. And off you go. You can register into your VNets. You can get your VNets to automatically register so that you get resolution within your virtual network very quickly. If you don't enable this, there is the standard DNS sort of find me inside of a VNet that we do automatically for you. Like you might have seen like internal.cloudapp.net, that sort of stuff on your virtual networks. That's just us because we do it as part of our platform. But if you want to customize that and have your own names, so you want to be able to get to server1.brightencloud.net, go and create your own private DNS zone and off you go. We also have now built, at last, private DNS resolver. So some of you may have heard of Route 53 resolver. We didn't have it. It really hurt us. So you did private link. You wanted to get to your service from on-premise. You can't resolve Azure DNS outside of Azure. Great, which means you now need a server or something in Azure that you can forward DNS requests to, so then it can forward its request to Azure DNS to give you a response. Customers who had Active Directory, happy days. They already had DNS in the cloud, perfect. People who were very cloud native, they're like, what's Active Directory? And you're like, yeah, okay. So we had this really long point of you just had to build like a virtual appliance that literally did a DNS forwarder, like a Squid proxy, or like lots of things that are out there you could do this with. We've eventually built a PaaS service that has been well needed that now does this service for you. So you can deploy a private DNS resolver in a virtual network. It will do the resolution for you. We manage it, we update it. It has really high query per second throughput rates so that it scales well. It spans availability zones, all of those things. But you don't now need a VM to manage yourself. You can pay us to manage the VM for you and do the DNS queries for you. You don't just have to use it for private resolution also. So you can do some cool concepts. So you don't even need to have virtual network peering and layer 3 connectivity to it. If you've got a private DNS rule set that is linked to a virtual network, it will get there just by the magic of the cloud networking. It will get to it and it will resolve. You don't need to have line of sight to the DNS resolver. So enable some pretty insane topologies, but helps you with complex network scenarios or overlapping address spaces again, common theme. But yeah, great service, been out about 6 months and very popular, as you can imagine. We've talked about routing preference, hot potato, cold potato. Networking insights, back to your question, Keith, a little while ago. There's a few more than 3 slides. We have something called Azure Monitor. It is your place to go for everything monitoring in Azure for all services. If you're trying to work out what's going wrong, there is a network insights blade that will tell you very quickly of all the things you've got access to, red, green, amber, what's going on. But then taking that one step further, you've got things called connection monitor, flow logging, and traffic analytics, which are enabled on a network security group that is attached to a subnet. So you need a network security group to start the logging process. That could just be allow everything everywhere. It doesn't, by default, they pretty much are that, apart from deny everything bad from the internet. But you can then dump all of those things into a log analytics workspace or a storage account, which then you've got all this JSON structured data, which this service called traffic analytics will then chew and go, by the way, this IP address was trying to get to this IP address on this port 50,000 times and it failed. Now, if all of that stuff's within Azure, it will tell you, and it's because of that NSG. So we'll do the hard crunching for you. We'll do all of that hard analysis for you. But if it's not, and say it's like a going to on-prem, it will say, it got to here and that's where it stops, right? So there is lots of tools that will help you with that. But Azure Monitor is your way into finding all the monitoring insights and enabling those. But traffic analytics is probably my favorite service because NSG flow logs looking at raw are not fun. And you go cross-eyed very quickly because there's lots of data and they grow. So traffic analytics basically crunches all that data and gives you a nice analytical view, keys in the name, traffic analytics, to help you crunch that data and understand what's going wrong. Then you can go into those logs and query them a bit more if you need to. But yeah, that's where I would start. And then we have Network Watcher, which sits on top of that. So it then is more like that reporting up the line. This is how much traffic's going in and around our network. These are the ports that are popular. These are the top talkers, that sort of stuff. Network Watcher builds on top of traffic analytics and crunches that data and gives you all of that sort of stuff. Helps you also do like packet level captures. So you can do packet captures at VPN gateways, VMs, all of that stuff, just into a PCAP format. And then you can take that out and do what you like with it. Just don't trust any of the MAC addresses you see because they're all fake because it's a cloud. They're all like 1.2.34.56. So yeah, it gets really confusing when you're trying to piece that together. But, that's it. But from a layer 3 perspective, it's really useful.